I am an assistant director and learning specialist here with ASPA. My office is downstairs. I work with a caseload of students and do some other stuff with the mentor program and disability services and that kind of thing. The reason that I'm talking to you about math and science is because my background is actually in math. I have an undergraduate degree in math. I tutored math for a long time when I was getting a master's degree, and that's really where my strengths lie. So a lot of what you're going to hear today comes from my background in math, but I think it's also applicable to the sciences and other things too, like economics and accounting and those types of things. Can I just get sort of a show of hands? How many people are primarily math tutors or statistics? How about sciences? Okay, and anybody like primarily accounting or economics or any of those? A little bit? Okay, all right. So I think there are really some unique challenges when it comes to tutoring math and science, and I want to sort of start by talking about those, and then the rest of the presentation is going to sort of come off of that. So the first thing I think is that a lot of students in math and science are unprepared. So this comes from a couple of different places. First, they might have had inconsistent K-12 education in math and science. So a lot of them moved between states and maybe the curriculum changed and they missed things, especially in math. Some of them have taken biology and chemistry in high school, but they've never taken physics or earth science. And they get here and they're expected to take geology and that sort of thing. So a lot of them just had inconsistent education in K-12, and that really affects their ability to do well in the science classes or the math classes that they're taking here at NC State. A lot of them are unfamiliar with basic concepts. So you math tutors probably notice that a lot of times you'll be working with a student and you'll realize, oh no, they don't know order of operations, or they don't know how to add fractions, or they don't know some of the basic things that really allow you to be successful in these math classes, or even just have a basic level of competence in those math classes. Taking time between math classes. I get a lot of students who really don't want to take math when they get here, so they wait until like their junior or senior year to take the financial math class. And it's been 3 or 4 years since they've taken a math class. They've forgotten everything they learned in high school, and it's really difficult for them to jump into that class. And I think that's really a big challenge for a lot of our students. And then unfamiliarity with college pedagogy. A lot of students went to high school where their teachers knew their names, they could follow them out into the hallway if they didn't turn in homework. There were 20 or maybe 30, that's a huge class for high school probably. Now they're gonna sit in these lecture halls with 200 other students, the professor doesn't know their name, there's 3 TAs, they're just not used to that environment. And for a lot of them, that's really a challenge. And so helping them work through that is gonna be part of what you guys can do. Another challenge that I see with math and science is low self-efficacy. Does anybody know what self-efficacy is? You're nodding your head. Yeah? Yeah?
No.
No? No? Okay, so self-efficacy is a person's own feelings and thoughts about their ability to succeed in a given situation or perform a specific task. So we distinguish self-efficacy from self-esteem, where self-efficacy is our feelings about a certain task. So we might have really high self-esteem, right? Because we're the quarterback of the football team, or we're a gold medalist in the floor by 100 relay, right? But we might have really low self-efficacy for our chemistry class, or our calculus class, or just math or science in general, right? And so students with low self-efficacy for learning tend to set really low goals for themselves because they think, oh my God, I just can't do this. So if I just pass this class, that would be fine. And they're not gonna put in a lot of effort, right? They're gonna give up easily in the face of challenges, and especially with math, that's really bad, right? Because sometimes you have to work and work and work at a problem or work at a concept before you're gonna understand it. And if you're giving up easily, you're probably not gonna do so well in that class. They put on a facade of knowing. So I'm sure you guys have all had students who get into tutoring and they're like, oh yeah, I know how to do that. We don't need to go over that. Or, oh, I'm just gonna work by myself today. And they're like hiding their paper, hiding their test grades, right? So that's that facade of knowing. They don't want you to know that they're confused, that they don't understand, and they're gonna put on this facade of knowing to kind of fake it. And that's part of why they don't want to feel vulnerable, right? They don't want you to know that they're really struggling. A lot of these students will just say things like, I'm just not good at math, or I'm just not good at science, I've never been good at it, right? We've all heard this. They probably struggled with math in elementary and middle school, and then instead of working hard trying to get better at it, they just wrote it off, right? They didn't challenge themselves, they didn't push to get better, right? If they struggled when they were younger, somebody probably said to them, some kids just aren't good at math, and they were like, oh, I'm one of those kids, I'm done, right? Again, they're afraid to seem vulnerable, so they put on that facade of knowing, and they have no confidence in their ability, and that handicaps their ability to even try, right? So if they're really scared, if they don't like math, if they think they're bad at it, it's gonna feel really uncomfortable for them to sit down and tackle a homework problem or tackle a problem set or whatever, and they're not gonna wanna do it. So what are some strategies for you guys to work with these students to sort of address these challenges, right? The first thing is encourage interaction with instructor. So we talked earlier about them not being used to the pedagogy, not understanding how the class works and that kind of thing. Encouraging them to interact with their instructor, even at bare minimum, if it's just going up after class and introducing themselves, so when they do have a question, they feel more comfortable, right? Encourage students to take control of their own learning and help them develop strategies to do so, right? So our students don't have a ton of autonomy. In general, they're told where to be, when to be all the time. If you can push them to sort of take control of their own learning, so when they walk into a tutoring session, they say, hey, in class today, we went over derivatives. I have no idea what we're talking about. Can you help me with that, right? That's going to give them some autonomy over the tutoring session. It's going to make them feel really good about what's going on there because they have control. Even though you guys are teaching them and you guys are helping them, if they sort of come up with the idea that, oh, we want to go over derivatives, that's going to push them to work a little harder in that tutoring session. Keep tutoring sessions low stakes, right? So let them make mistakes. Show them it's okay to make mistakes. If you make mistakes too, that's fine. When you keep the tutoring low stakes, they're not going to be afraid to be vulnerable in front of you. They're not going to be afraid to say, hey, I don't remember how to do order of operations. Can we go over that? Or I don't remember the parts of a cell. Can we go over that? Those types of things. Encourage a growth mindset. Okay, so a growth mindset is the idea that intelligence isn't fixed, that students can learn more through hard work, right? So we want students to know that just because they've been bad at math for 18 years doesn't mean they can't get better at math now, okay? So intelligence can grow through hard work, through studying, through interaction with their tutors, through interaction with their professors. We want to encourage that mindset. If they think that they just have a fixed mindset, that no matter how hard I study, no matter how hard I work at this class, I'm never going to get better at it, then what's the point of working hard, right? So we want to encourage this growth mindset. Okay, so a couple ways to do that. First, praise the process, not the outcome. I say this for everything. So if they get a really good grade on a test, or they get 100 on a homework or something like that, definitely praise them, absolutely. But you want to focus on the work that went into that grade instead of the grade itself. So you want to tell them, hey, I'm really proud of you, you worked so hard and look, it paid off, okay? Instead of saying, great, you got an A. You want to encourage working hard as a means to achievement. So even sometimes when there isn't a grade to praise, sometimes it's good to just say, hey, you worked really hard during this session, I think you're going to do better. Or, you finished that whole homework, that's awesome. Those types of things. Encourage students to set achievable micro goals. So sometimes it's just, hey, you're gonna finish the homework by 5 o'clock every day. Or, you're going to understand and memorize this formula, or those types of things. Just little micro goals to help them see the progress as they're moving along. Encourage the value of the learning process and collaborate, and we're going to talk about collaboration just a little bit later. And then the last thing is take some time to go over basic concepts and to continue to review as the semester unfolds. So just like I said, like sometimes students come in and they just lack that foundational knowledge, right? And so some of the things that I've seen, and I mean, I've done math stuff for a long time, so I'm better at knowing those things than I am at the math stuff. But like fractions is a huge thing. Like, students seem to really struggle with that. They don't know how to add fractions, they don't know how to multiply fractions, they don't know what the concept of a fraction is. Percentages and decimals, I work with a lot of students in the financial math class, and I always have to review, like, how do you go from a percentage to a decimal, and what's the difference between those, and all that kind of stuff. Order of operations, basic algebra, just solving for x, those types of things. Substitution, factoring, FOILing, and exponents, all things that I've seen that students have struggled with that have really hindered their ability to succeed in those math classes. And then in terms of the sciences, things that I've worked a little bit with students in the science classes, just like for chemistry, like knowing the basic elements is really helpful. Parts of the cell, human body systems, cellular reproduction, DNA and genetics, mostly just like the concepts and what is DNA, what are genetics, those types of things. Tectonic plates and Earth's atmosphere and core, mostly because a lot of students take the geology class and those basic concepts that they're sort of expected to be familiar with, they're often not. Okay, any questions so far? Okay. So I want to go over some session strategies, and the first thing is just basic stuff. So a good way to start the session is to use something called the tutor cycle. This will sort of help keep you both engaged the whole time. I know sometimes you walk in like the first day and it's like sort of awkward, you're like meeting the student and you're expected to help them, and sometimes they're not super excited to be there. And I think this is a really good way to just sort of like keep in your mind, like, okay, I'm just gonna go through these steps and everything will be fine. So this is the tutor cycle. The first thing is just greet the student, introduce yourself, tell them a little bit about you, give them an opportunity to tell you a little bit about them, and then just sort of set the climate. So be open to them, understand that they may take a little bit to get to know you, to feel comfortable in the tutoring session, understand that this isn't their favorite thing to do, and just be sort of supportive and those types of things. And then identify the task. So I usually ask my students, hey, what do you want to accomplish during the session? What do you want to work on? I have ideas about what I want them to work on, and sometimes they'll be like, well, I want to just, do my USC 103 homework. And I'm like, well, that's not really a good use of your time, so let's do this other thing. So you probably have ideas of what you guys want to go over in this session, but give them an opportunity to identify something that they want to work on. And then restate that so that they can clarify and elaborate if they need to. And then your job is to identify the underlying process. So this is the point where they say, I want to go over derivatives. I didn't understand derivatives. And give them an opportunity to clarify that. What did you guys do in class? Did you, what rules did you go over? Did you go over exponent rules or multiplication rules or whatever? Give them an opportunity to clarify, and then talk a little bit about them, about derivatives with them, and what is a derivative, right? So when we take a derivative, we're finding this locally tangent line at a specific point on the curve. Talk about that a little bit, so they're not just memorizing, oh, if I'm taking a derivative, this is the thing that I do. They understand really what that process is and why they would need to do it, okay? And then set the agenda. So if you're talking about derivatives, so you say, hey, let's spend 10 minutes, I'll go over derivatives on the board, and then the rest of the session we're going to do some practice problems, and you're going to get up on the board, you're going to show me what you've learned, okay? You might just want to review class notes. If you have multiple students in your session, you might do a little student collaboration. That's always good. You might play some games at the end. Whatever you guys want to do is fine. But set the agenda, be flexible, and you can do that, just say, hey, this is what we're going to do. Or some students like to just put on the board, like, okay, first we're going to do this, then we're going to do this, then we're going to be done. And that might help them just stay on task, especially if you have students who tend to get off task really easily. Sometimes it's good to put an agenda on the board and say, this is what we're going to get done during the session. And then you're actually going to do it. So this is like the majority of the session, right? Those first two steps don't take up too much time, hopefully. And then you're going to address the task, right? So a couple of things to keep in mind. make sure that you are connecting underlying process you discussed to the task at hand. So if you talked about what derivatives are, right, when you guys are doing that, make sure you're connecting back to that, okay? Ask lots of questions of the student, okay? Help them come to their own understanding if possible. So if they ask you a question, maybe you spin that question a little bit and you ask them something back that's going to jog their memory or turn the light bulb on or something like that. With that being said, don't let the student become overly frustrated. There are times where you're just going to have to answer questions because you're going way back. They do not understand what they're talking about. They don't understand what's going on in class. And you have to explain it a little bit. Avoid the temptation to fall into the instructor role. So you're here to guide their learning, right? You're not their professor. You're not their instructor. You're not expected to be. So you want to guide their learning. You want to help them with things that they don't understand. But you don't want to be standing up on the board for a whole hour teaching them things, right? They should be actively engaged. They should be doing problems. They should be reading their chemistry book and explaining to you what was in the book. They should be actively engaged, okay? So you don't want to fall into that teacher role because you're not paid for that. And then make sure you check for understanding, right? So there's a million ways that you can do this. You can have the student teach you back what you went over in the session. That could be just 5 minutes at the end. Hey, you get up on the board, teach me what we went over during this class, right? Tell me what you know. Show me how much you learned during this session. You could quiz them on the material that you covered. So if you're doing parts of a cell, draw the cell up on the board and say, hey, go and label it, okay? Having them complete a problem on their own. Sometimes we forget and we just let them ask questions of us while they're doing problems. They've never completed a problem on their own, and they get to the test and they're like, I didn't know how to do it. So to have them, push them to do something on their own at the end of the session, have them connect what they are learning to something that they've already learned. So this is, I think, especially good in the science classes. Like, oh, we learned about cell reproduction, and that's like, when we learned about this other thing, or whatever. Connecting the things that they're learning now to something that's previously learned, that's going to help them remember it, and it's going to make sure that you know that they're understanding what they're learning. And then the last thing is just close the session. So identify the tasks the student should accomplish before the next session. That might be, hey, you need to finish your homework, you need to read chapter 3, you need to do this problem set, you need to, do a lab, whatever. Evaluate the success of the session. So think about what happened during that session. Was it successful? Was the student engaged, right? What techniques worked? What didn't work? Sometimes I'll come up with this great idea in my head that I'm gonna have a student do something, and in reality, it doesn't work at all. And sometimes that happens, and that's good to know that that thing didn't work for that particular student. And when you're constantly evaluating, you're gonna constantly be getting better. And include the student in the evaluation. Sometimes I'll just ask them, hey, how do you feel? Do you feel like you understand that? What can we do differently next time? How do you think this worked? That kind of thing. And sometimes they'll be brutally honest. I didn't get that at all. But sometimes they'll say, yeah, that really helped. When you connected it to this other thing that we did last week, it sort of clicked for me and I got it. So sometimes including the student in the evaluation is helpful, and sometimes it's not. Okay, and then I wanted to just go over some session best practices. So, during the session, reinforce correct procedures or answers. So just make sure that you're telling a student when they're doing it right. Just that building of their confidence is going to help them keep going. It's going to help them be vulnerable, make mistakes, those types of things. Teach concepts over processes. Sometimes it's really easy to be like, just divide by this, and not tell them why you need to divide by that, or that kind of thing. Teach the concepts over the processes. That's going to help them learn so much better than just memorizing a formula or memorizing an algorithm. Teach the concept. Have the student re-explain concepts or problems to you. So we talked about that sort of at the end of the session. Just have them teach you. Have them re-explain what they're learning in their own words. A really good warning sign is if they just repeat something word for word that you said. They don't understand it. They're just memorizing what you said and repeating it back. So have them explain it in their own words. Link old information to new information. That's how our brains work. That's how our memories work. We want to link the new things to the old things. So if you can help them do that, that's going to be really helpful. It's going to help them learn better, memorize better, and understand better. Help students find ways to logically organize information, especially for these science classes when there's a lot of information and a lot of material to memorize and understand. If you can help find a way to logically organize that, like the animal kingdom, right? There's a logical way that that is organized. So help them see that logic, help them understand how it's organized. It's going to really help them remember it better. Encourage elaboration, analysis, and critical thinking. So again, for science classes, I think this is huge, but also for math classes too. This isn't high school anymore. You can't just memorize a bunch of definitions or a bunch of formulas and expect to get an A on the test. So you need to push them to think a little bit further, to elaborate on the concepts that they're learning, to be able to analyze the things that they're learning, and to critically think. And when we can push them to do that, they're going to do a lot better. Sometimes I have students who come into my office and they'll say, I just took this math test and I did not recognize any of the problems on the test. They were totally different than the homework. And I'll look at the test when they get it back and it's like one or two words are changed, or maybe it's like a different, instead of, you know, the interest rate being compounded monthly, it's daily. And that totally throws them off, right? But if you can encourage them to think a little bit deeper, elaborate, analyze, they're going to take those problems in stride. They're not going to be handicapped by that. And again, just encouraging students to go beyond surface level thinking is really important. Okay, exam review. So this is the big thing, right? We want to make sure our students are doing well on tests. A lot of students struggle with test taking, so I wanted to just do a special slide on exam review. So first things first, start early. Starting the day before the test, especially if you guys only have 1 hour sessions, it's probably not going to do that much. So make sure you're starting early with exam review. And sometimes that's just when a student comes in and they're feeling really unmotivated, unengaged, and they have a test next week, you can say, hey, let's get a lot done during this session because you have a test next week and I want you to be prepared. Use the study guide if one has been provided, but make sure you get it approved. I'm sure Kristen went over that this morning. Use the web assignments that have already been graded to review. I think that's a really good way to study. Even if they don't finish the web assigns or don't get the answers are on the web assign. So you can look at the answer keys once it's been graded, and that's a really good way to test their knowledge because you know what the answers are. There's often